Hello everyone and welcome. My name is Liz Pemper and I'll be your moderator for today's WJE webinar, Navigating Honolulu's New Residential High-Rise Fire Safety Ordinance. During the next hour, WJE Structural Engineer Mike Greer and WJE Fire Protection Engineer Garner Polinsky will review the events that led to adoption of the new Honolulu High-Rise Ordinance, clarify the submittal requirements and schedule for compliance, and provide recommendations to help building owners and managers effectively prepare. And now I will turn it over to Mike to get us started. Mike?
Thank you, Liz. As Liz said, my name is Mike Greer, and I'm a structural engineer and manager of the Honolulu office of WJE. And I'm going to go over a little background about Honolulu's new residential high-rise fire safety ordinance. So to start, we'll start with some learning objectives for this presentation. By the end of the presentation, you'll be able to do 4 things. 1 is to identify the high-rise residential building fire challenges. 2, outline the specifics of Ordinance 19-4, including schedule and submittal requirements. 3, interpret the elements of the city-developed fire life safety evaluation matrix. And 4, describe common non-compliant conditions found during site visits. So, a little background. The story of the ordinance starts with the Marco Polo condominium building. Marco Polo is a 36-story concrete structure located in Honolulu, Hawaii. Construction of Marco Polo was completed in 1971, and Marco Polo is not protected with a fire sprinkler system, which we'll get into a bit later in the presentation. On July 14th of 2017, a 7-alarm fire occurred at the Marco Polo building. The fire started on the 26th floor in 1 unit and spread to 12 units over 3 floors. As a result of the fire, there were 4 deaths and 13 injuries. 200 units were destroyed or damaged, resulting in approximately $100 million in damage. The cause of the fire is still undetermined. To give a little idea of the scope of the fire, I'd like to show a quick video. So here in the video, you can see something important to note is the direction of the smoke, which the prevailing winds in Hawaii are from the northeast, and you can see that's prevalent here with the way the smoke is going. In this portion of the video, you can see the fire spread to multiple units. So here, it's in multiple units on different floors. So, a little background about fire sprinklers. Fire sprinklers were required for new high-rise construction in Honolulu starting in 1975. Now, much like the Marco Polo building, many buildings in Hawaii were built prior to 1975. There are approximately 300 residential high-rise buildings that are not fully sprinklered on Oahu. Fire sprinklers are intended to control and prevent the spread of fire from adjacent units. So the story of the ordinance starts with Ordinance 18-14. Now this ordinance was created as a response to the spread of the fire at Marco Polo, and it was meant to address fire safety of high-rises. Specifically, Ordinance 18-14 amends the fire code of the City and County of Honolulu and establishes an evaluation process for existing high-rise residential buildings in order to implement life safety improvements. Honolulu Ordinance 19-4 amends Ordinance 18-14 and specifically amends the section entitled Installation of Automatic Fire Sprinkler Systems. The ordinance creates the alternative Building Fire and Life Safety Evaluation, which is based on the chapter of the National Fire Protection Association guide listed here. That chapter is entitled Fire Safety Evaluation System for Board and Care Occupancies. One of the specific edits is this section listed, and specifically states that compliance shall be with either an automatic fire sprinkler system throughout the building, or if required, an alternative fire prevention and fire safety system. The alternative to sprinklers is a fire and life safety evaluation, which consists of an assessment of building safety features and fire protection systems. So a little bit about the timeline of implementation. Ordinance of 19-4 requires a building and safety evaluation to be completed and submitted to the Honolulu Fire Department by May 3rd of 2021, so approximately 1 year from now. Any repairs identified in the evaluation should be completed by May 3rd of 2024. Sprinklers or alternative fire prevention systems should be installed building-wide by May 3rd of 2030. Common areas may require sprinkler installation or alternative systems sooner, depending on the building's number of floors. If the building's 20 floors or over, it will be required by 2026, or 10 through 19 floors by 2028. To discuss a bit more detail about the evaluation process, I'll now pass it over to my colleague, Garner.
Hello, this is Garner Polensky. Good afternoon, and special hello to my Hawaiian friends who might be listening. I'm going to pick up where Mike left off and discuss really the two options you have, might be more, regarding the sprinkler installation ordinance. And those two are sprinkler in your building or passing the fire and life safety evaluation. And we'll go through the pros and cons of those right now, or the advantages and disadvantages. So the sprinkler system is the primary option for you. The pros to that are advantages. Clearly, sprinkler system provides superior fire protection. It saves lives, reduces property damage, and can result in lower insurance premiums. Reliability is quite good. Kind of on the disadvantage side or the con side, the cost is rather high. For our budget estimates, we're using approximately $15 a square foot. That doesn't include abatement of asbestos and those types of things. The other con that people don't realize is that the sprinkler system needs to be monitored by the fire alarm system of the building. And you monitor the water flow. In case a sprinkler breaks, you would know it happens. It reports to a central station, or if somebody closed a control valve. So depending on the age of your building and the type of fire alarm system you have, you might have to upgrade or replace your fire alarm system to provide that monitoring capacity. And that can be quite expensive too. The installation can be inconvenient. You would typically do this in phases, which requires people to not be in their units or something else to accommodate the workers. And finally, there's increased maintenance costs because there'll be a fire pump associated with the sprinkler system, and that has to be maintained on a weekly basis, mostly just exercised and that type of thing weekly. But there is a good place for the fire sprinkler solution. There are certain buildings that it'll be the best option and certainly could be the cheapest option too, least expensive. And that are buildings that have extensive vertical shaft issues. And that would be the fire stopping is non-compliant, or the stairs and elevator enclosures are not rated. Those are required to be 2-hour rated, and going back and improving that to 2 hours should it not be compliant would be very difficult. Also, buildings with extensive corridor rating issues, unprotected openings, windows cut in the corridors that aren't rated, or construction issues, just non-compliant construction. So the sprinklers do offer a good opportunity for those types of buildings, and it would probably be least expensive compared to the other way to solve those. Now, the fire life safety evaluation option, obviously the advantage is it provides an acceptable level of safety. It's cost effective, clearly. It's less inconvenient. Probably there's an engineer on site for 2 or 3 days, and that's about what you have to do. And there's no additional devices to maintain. On the disadvantages, it provides a reduced level of safety compared to sprinklers. And certainly if there's a fire, there'd be increased property damage. When I think of the, excuse me, when I think of the fire life safety evaluation, I think we're really returning to the original fire life safety strategy of these buildings. And that would be the strategy they're designed to have in the 60s and the 70s. And that would include prompt notification of occupants who are intimate with the fire. They have to move away quickly because they're the most threatened. Confining the smoke and fire within the room of origin. Notifying or providing safe occupant egress, and notifying other occupants to evacuate the building that may not be close to the fire. Notifying the fire department promptly, and facilitating firefighter operations. I think one way to look at those strategy elements would be reviewing the Marco Polo fire, which occurred on July 14th, 2017. So we're going to go through this a little bit, as much as we can fit into this presentation. But I'd like to mention this is a exercise for illustration purposes only. So this is based on my research and review of the incident report. I didn't do it to the forensic level I would if I was retained to evaluate the fire. But I think it gives you a good idea of what happened and how all these components of the fire safety strategy fit in. So as you can see on the screen, to your left is a floor plan of the Marco Polo Tower. That's public domain. I got it off the internet. You can see on the day of the fire, as Mike noted, the trade winds were blowing from the northeast towards the building. You can see the directional arrows. That's really important because the trade winds drove the smoke through the building. And we'll talk about the opening. So a critical weather event that happened at the same time as the fire occurred. And they're 16 to 20 miles an hour reportedly. The area of fire origin is unit 2602. I have that clouded, if you will, up there. You can see the O2. Also shown are units 26, 13, and 15, where the 26-story fatalities occurred. In unit 2602, the day of the fire starts at approximately 2:17 in the afternoon. One occupant is sleeping in the living room and one sleeping in the adjacent bedroom. The solid core door, front door, was open with a screen door shut across the opening. The lanai sliding glass door was open, as were the windows in the bedroom. Wind forces blew the door between the living room and the bedroom shut, which really did provide additional protection for the bedroom occupant. The occupant in the living room is awakened to the sound of a smoke alarm nearby. He didn't know where it was. Reportedly, he thought it was an alarm clock, as he discussed. He did witness smoking or smoldering combustion at first, meaning the fire hasn't got past the incipient phase, and then it turns into flaming combustion pretty much before his eyes, as he describes it. So when you think about it, our first element of the fire safety strategy is accomplished. Good news, that there's prompt notification of the occupants intimate with the fire. So the living room occupant opens a door, goes in the bedroom, gets that person who's asleep, wakes her up, and they both egress through the smoke out the front door. So the smoke was already dense in that room. I can't tell you the level of the smoke in there, but visibility was notably difficult for the occupants to get out. So they went out the front door, they opened the screen door, went out the front door, and they didn't shut the solid core door behind them. And that's a fatal mistake that changed the whole direction of this fire. If there had been a solid core door on a closer device, it would have shut automatically, or if they would have shut the door, the fire would have been maintained in the unit of origin, vented to the outside as it did, and not transfer all the smoke and heat into the building. So on that one, confine the smoke and fire within the room of origin, I think they get a negative mark, they being the criteria here. So the smoke travels through the corridor and into the units that have unprotected front doors. And again, that could have been stopped if we had a door go across the opening of Unit 2602. The smoke migration is aided by the trade winds, and the smoke enters multiple units, that would including 2613 and 15, again, where the fatalities occur. So going through the other criteria, from what I can tell, the exiting system was compliant for the building. However, tenability got really bad in the corridors, really bad being a technical term. And it got such that the visibility was bad and potentially very warm in there. So I'm going to give a negative mark on provide safe occupant egress. Based on the reports, witness reports in the report, the fire alarm system didn't activate and notify people remote from the fire. Now there's conflicting information on that. The building engineer said he heard it. Occupants, I didn't read all the testimony, but the occupants said they did not. I'm giving a failure on notify other occupants, which is important because that gives occupants the opportunity to try to decide what to do. I've done forensic cases on these type of fires, and one I dealt with in Los Angeles, pretty much the same thing happened. The difference was the fire alarm system went off, and occupants were actually realizing there's an alarm condition, stayed in their units. They were actually phone calling the fire department who told them to stay. And the only people that didn't come out that day were the people in the room of origin, which is kind of, the goal is again to confine things into the room of origin. Now, notification of the fire department, the best I can tell from reading the testimony is that a passerby walked into fire station number 29 and alerted the fire department of the fire, and then they went into alarm. So I would say the notification of the fire department wasn't prompt. And then the fire department arrived ready to fight the fire, and they went to the stair that didn't have the standpipe. There's only one standpipe and two stairs. So that delayed their response to fighting the fire a little bit. So pretty much a -1 on that. As you can see, problem with one of the most important elements of the fire safety strategy, just one thing would have made this fire completely different, probably not fatal, much less property damage. So we use fire models to predict what happens in fires. They're complicated mathematical models, and we can tell conditions when the fire occurs, where the smoke goes, how hot it is it toxicity, a bunch of things. So we built a model to look at this. Now I would say that we didn't use the exact dimensions of Marco Polo. That wasn't the intent, but we did use similar characteristics. So what you see in front of you is the simplified video output of this model. And you can see the yellow band going across horizontally. That would be the corridor of the building. And you can see two parallel units. The one at the top has a little orange rectangle on the bed, and that indicates where the fire is. I believe we assumed there was a laptop on the foam mattress, and that went into ignition, and then we did heat transfer to get the bed to ignite. And you can see the furniture, and you can see a door in the unit down below, the lower unit. There's also a door in the upper unit that's going to open in the simulation. And what that's going to do is simulate the fire activating and the detector going off, then people making the travel to that door and opening it, and then leaving it open, and you can see what happens. The green rectangle you see behind is the exterior of the building. And even though you can't see from this perspective, we're going to assume that the sliding glass door in the lanai is open, and you can see what the smoke does. So this is pretty much on autopilot when I click this button. So we're going to watch it once. It's not very long, it's a minute. Then we're going to watch it again so you can get a good feel for this. So let's take a look here. So watch the timing. You can see in the right-hand corner, lower right-hand corner, you can see the smoke. See how the smoke is bent down? That's being biased by the wind speed. You can see the smoke going out into the green outside. And now the door is going to open when the people go out and they don't shut it. And take a look how the smoke migrates. It goes directly into the unit across, and the corridor gets filled with smoke also. So let's look at that again. I know you're enjoying it. And we'll watch it, be watching how the smoke is being biased and where it moves. And look how quickly the smoke fills the unit across from the unit of origin. The door is going to open in a moment, and you can see the smoke goes right down the corridor. We usually judge the tenability of the corridor, the safety of the corridor, by how low the smoke is, first order approximation that is. And if the smoke is less than, if the smoke gets lower such that a 6-foot person couldn't walk under it, smoke layer height, 6 feet, we believe that to be threatening. Now we can do other scientific things with that, but that's a general guide. So this just shows you how severe that smoke movement was. If we ran the model that we had with the doors shut, it'd be completely different. The fire would vent out the lanai door, and everybody inside would have been in a much better position. When I'm walking around in Hawaii doing these evaluations and people are talking to me about what am I doing and all that, they're wondering about it, or when I go out to dinner, my friends say, what's up with this? I think it's interesting to hear what this involves, and it might be a little different than you think, maybe not. So I came up with this slide, what to expect when this happens, and it gives you kind of an overview of what would happen when you retain somebody to do the fire life safety evaluation. So let's talk about the pre-survey preparation. So usually there's conversations between the property manager, the AO representative, and the resident manager to determine, you know, the scheduling, when we're coming out, and to go over the parameters of what we're going to look at. And we go through pretty much a lot of what I just said, the intent of the building construction and what it all means. We do have another concern now with the COVID-19 problem, and that's just requiring more coordination. Our firm really has a policy now that we're not doing many site inspections. And I know Honolulu is in a quarantine scenario, at least partially. So that is causing some schedule delays, but I don't know it's really a big issue at the moment. Now the site visitation is site survey, if you will. That starts with a document review. And for you owners out there that are going to be doing these, it's really important that you try to gather up all the building plans and fire protection testing records you can find, because those really are valuable, very valuable for the engineer coming out to do the evaluation. So then the site visitation begins with, in earnest, the building observation. So I'd say that's a 1 to 3 day venture, depending on the size of the building and the complexity. And the engineer should be going through all the common areas and representative number of units. And that's primarily to go in the units to confirm the smoke alarm situation. Are the smoke alarms in place? Are they maintained? Do they work? Etc. Also, something that's really important and pretty difficult to accomplish is inspecting the vertical shaft enclosures. And that would include the trash chutes, not my favorite thing to do, but certainly there's a high frequency of fire in trash chutes statistically, so it's something we would address. Then going to the stairs, the elevator shafts, and taking a look at all the other vertical shafts, because they're one of the main ways that smoke moves vertically through a building. So those need to be enclosed, not open or penetrated by pipes and things. Speaking of pipes, fire stopping is a big issue. And what fire stopping means is you have a pipe that's traveling through the building and it penetrates a rated wall, fire rated wall. So what are you going to do The code requires you to seal that so smoke doesn't go through the fire-rated wall and ruin its integrity and allow the smoke to move. That would apply to piping, ductwork, and all that. So there's a sealing protocol to do that. Usually use a listed material and follow a listed assembly type. Ducts could get dampers, etc. So that's very difficult to observe. And usually we're using plans to do that and then doing spot checks to confirm that. Following all the fun on the site, there's usually a post-site work conference where the general findings are explained. Then your engineer is probably going to go back to his office and start working on the report. So for us, we spend a lot of time on the report. We go to client meetings, providing consultation on various options or concerns the client might have. The report's sent to the client, revised, and then it's required to be submitted to the Honolulu Fire Department by the consultant. So the consultant needs to seal the report with the license of the engineer and responsible charge. So even if the building fails, that still gets submitted. I was just talking to the Honolulu Fire Department about an hour ago, and they were making sure I understood that we want to get all those in as quick as we can so they can get an idea of the progress of things. So that would get submitted, and then we usually have department discussions with the fire department regarding things. Now, if the building fails, you still got to submit by the deadline, but you probably go into the mode of building modifications. What are you going to do? Our firm developed a tool from some work we did in Chicago that gives us a way to kind of sort through the variations you can do and combinations of the different improvements you have to do for the benefit of the client. So once that's done, it's resubmitted. The evaluation is resubmitted to the Honolulu Fire Department, hopefully with a passing mark. And if all that doesn't work, you go into the phase of sprinklers are required and retaining contractors and that type of thing. Everybody keeps asking about what this big evaluation thing's about, and fundamentally, it's pretty simple. It's an Excel spreadsheet tool developed by Honolulu Fire Department and a committee of fire experts. And simple, what I mean is you're inputting numeric values for different factors. Really doing that properly may not be so simple, but it's rudimentary math with the Excel spreadsheet, and it gives you numbers that tell you pass or fail. And we're going to talk about that a little bit. Hopefully it won't be too boring, but I think it might give you a perspective of what it is. You would start out finding the risk factors for occupants and firefighters. So that's determined by mobility of the population that occupies the building, the occupant load, and the number of floors. And then from there, you assign points to various values of the elements that you inspected when you were out at the building. And the key values you have, I think there's 16, criteria 16. That includes what the building's built of, the construction type, the egress system, smoke management, does it have a smoke control system, the vertical shafts we talked about, does the building-wide fire system function? The matrix doesn't really go into what that means, and that's when the background of the engineer comes in handy to try to work through that and figure out the parameters. Are the smoke alarms in place and what the emergency power is? If you look on the right-hand side of that slide, which is pretty small, that's the primary input sheet of the matrix. We'll look at a better magnification here. So this slide, in fact, is that. So here's an example of the evaluation criteria. So this is what we would be looking at. You can see this one is about exit access. It has interior corridors, and then it gives protocol on different characteristics. Note that exterior exit balconies, those are the buildings that have the corridor that isn't covered. We call them exterior exit balconies because it's a code term. Gets a lot of preference. For example, if you look all the way to the right, interior corridors, the best score you could get would be 2. And this is a mathematical scale, so negative is bad and positive is good. And if you look at the exterior exit balcony score, you can get +8. You would go through and pretty much look at the condition of the building, then fill this out, and the Excel spreadsheet totals that for you. Here's another one. This is fire safety parameter values. You can see this shows the input, the little red number 2. So you're selecting the construction type of the building, type 4 and 5 are combustible, 1 and 2 are not, and making choices there. Something that's really hard to determine is the interior finish. So the interior finish is important because that really dictates the rate of flame spread in the fire, and certainly the size of the fire. So there's limitations in the current code regarding what class that is. Class A would be good, the flame spread rate is lower. Class C, not so good. And I found buildings that have wallpaper on them and it's circa 1970, what are you going to do with that? So the way we solve that is usually get the material and see if we can find submittal information from the manufacturer, or conduct flame spread fire testing at one of the labs available, potentially ours in Northbrook. That's a difficult thing to find. And you can also see the last one on this list is corridor and dwelling unit separation. Gives different numbers for different situations. Again, goes back to the keep the fire in the room of origin idea. So the calculations are then completed by the spreadsheet. If all criteria pass, the level of fire safety is acceptable. If not, you look at the possibility and combinations of various things you can improve, or last resort could be the automatic fire sprinkler system throughout the building. So when you get to table 8 and look at it, you want that red box to have an X in it or a yes, and that shows you have an acceptable level of life safety. I was thinking about the whole situation of this ordinance. I've been through an ordinance in San Diego and also in Los Angeles, and I worked on the first ordinance for hotels, transient residential buildings, quite a long time ago, and we did a bunch of outrigger hotels. But I was just trying to understand this better. Think about it. We're about a year from the first deadline of the evaluations. And I think the number now, 1/3, which it could be 1/2 to 1/3, according to the fire department representative I just talked to today. 1/2 to 1/3 of the total number of identified buildings have been evaluated. We're a year away. So if this trend continues, you would wonder about the manpower to make the corrections that we need to make. For example, are there enough contractors on the islands to make the needed repairs by 2024? Or look at the bigger picture. If we have 300 buildings, you know, it's plausible 1/3 of them would need sprinklers, so that's 100 sprinkler systems going up. Is there enough contractor depth to cover that? So I'm concerned about that. You all that are involved in the ordinance, I'm sure you're giving that some thought also. Let's go over the common deficiencies we see when we go out to these buildings. It'll give you a good idea, and maybe even you property manager folks that are on the line here, you might be able to kind of size up your own building a little to get some perspective of good, bad, etc. So lack of smoke alarms is the #1 problem we see. And you can see from the Marco Polo example how just vital the smoke alarm is. Really, in a residential fire, it's your primary protection because it gets you the heck out of the fire condition as quick as you can. So we find a lot of smoke detectors that are missing. Somebody took the battery out of them. They're not tested, and other things I wouldn't want to talk about, all kinds of uses for a smoke detector or smoke alarm. So this is a vital function and certainly a big concern. I've noticed that some AOAOs have programs where they're responsible for the smoke alarms, including testing and maintenance. One group I work with actually color codes batteries and by date. So when they do inspections, I think it's quarterly or monthly of the smoke alarm battery, they can tell how old it is, and then they decide to replace them or not, and they're very involved. Another building has wireless smoke alarms that send a signal down to independent panels, not the fire alarm panel, and they can monitor the battery health. Is it charged? Is it losing charge? Whatever. And they actually send that to the security department in the hotel, and the security staff will go up, change batteries, repair the detector or whatever. They're quite involved. Other AOAOs have a problem because it's intrusive to do that when you have ownership issues within the condominium. So we have all varieties of involvement. I really think there should be some program because the smoke alarm is so important. If you wanted to know, the smoke alarm requirements are one smoke alarm on the ceiling or wall outside each sleeping unit, then of course one in each room used for sleeping. So those are kind of vital. The one outside obviously tells you when you're in your bedroom something's outside, and vice versa. We talked about this a bit already, but this is a good visual look at the fire stopping issue. So if you look to your right, you can see, looks like a brick wall with horizontal piping. Could be chilled water or something. It seems to be insulated, or hot water going through that wall. So if we assume that's a rated wall, fire rated wall, that opening you see that was made for the pipes to go through would certainly compromise the construction of the wall. Smoke would go through that, and the wall would have minimal effect in stopping the smoke. The one to the left is interesting. That looks like a vertical piping, and seems like it's plastic tubing type piping. The one on the right could be copper, and it's penetrating the slab. These are kind of easier to find because you would typically find this in a closet, and you could verify if this was done right. When you do this, there's rated fire stopping material you have to use, and the application specifications are dictated also. You can see all the way to the left, there's just an open sleeve with no pipe, so smoke could travel through that. And just the application of the fire stopping looks pretty sketchy. So again, this allows smoke to move vertically in the building and is a really big problem, especially when we do these evaluations. This is a photo of a corridor, obviously. I'm surprised how many buildings I see that have, they're beautiful buildings, but they don't have self-closing doors, or the doors are damaged. And the way you do the self-closing door would be on the right-hand side, the little closer. You could buy those probably at Home Depot. But again, a very inexpensive repair you could make. Even replacing the doors is not really that expensive either. So again, a very common deficiency, and something that can be handled relatively inexpensive and would make a major difference in the life safety. And then we get to jealousy doors or windows. Didn't really know what to call these, and it's basically a glass louvered window that you can crank open to get the air to come through. You can see the what circa 1950s or 60s ad I have here. I didn't really know what these were called. In the house I grew up in Orange County, we had these, and I'm familiar because I spent a lot of time replacing the glass panels that I had broken for various reasons. But anyways, they are commonly used in corridors, and that provides ventilation in the corridor. It does compromise the integrity of the wall and allows smoke to move into the unit and expose people. There is good news on this, though. Looking at how these are installed quite frequently, I think they can be removed, and then a tin can, slang term, stud assembly could be placed in that opening, and probably gypsum board put in pretty easily, and probably not very expensive either. So this isn't one of those deficiencies that is not solvable in a simple fashion. So let's see, how are we doing on time? Oh, right on time. So concluding, the Marco Polo fire of July 2017 changed the landscape of high-rise residential buildings, fire and life safety forever. The Honolulu Fire Department reacted by establishing minimum standards for the safety of these buildings. That includes an installation of a fire sprinkler system or passing the fire and life safety evaluation. Completion of either of these options will result in an improved level of life safety for the residents of Honolulu. And I think that concludes. Thank you. You can see our contact information, and I believe we'll be going to questions and answers now.
All right. Thank you, Garner, and thank you, Mike. As a reminder, if you have a question, please type it into the Q&A box and hit submit. And if we don't get to your question during the call, we will follow up with you afterwards. All right, let's go ahead and take our first question. Why did the fire spread outside of the unit of origin and cause so much damage?
So I can answer that, Liz, if you like.
Sure, go ahead.
So when you think about that fire, we know the fire burned very hot, and that is definitely a post-flashover fire. So what that means is the heat in the room gets so large that the smoke becomes really hot, and there's actually more energy coming from the smoke that's heated than the fire burning. And that radiates energy back to the floor and it goes into flashover. You've seen it on TV, backdraft flashover. And it burns all the horizontal surfaces and ignites them really quickly. So perspective is 600 degrees C, maybe at, what is that, at 1200 degrees F. That smoke is very hot when it's being blown out of the unit of origin. It goes right into the other rooms, and it's very hot. It starts radiating energy down and igniting in that area too. Because if you look at, 2613 and 2615, there's major damage in there too. Now, the progression through the building, the smoke is buoyant and it's being driven by the wind. It's going to go horizontally first, any place it can. And I think a large percentage of the building had open doors with only screen doors. And then it's going to travel vertically. You could also see the smoke coming out from the room of fire origin, as Mike noted. It's very hot and buoyant, and those trade winds are blowing it back into the open lanai doors, and it goes right back in. So I don't know how much, as we got up farther in the building, how much damage was attributed to thermal damage, because you would expect that smoke to be quite hot, but cooling as it goes up. But certainly in the lower floor, it did quite a bit of damage. So that's the reason the smoke was very hot.
All right, excuse me, we'll take our next question. Could you please clarify how coronavirus is affecting the investigation?
I'll handle this one, Liz, if you don't mind. So coronavirus has obviously had some AOAOs a little wary about having, our staff doing the investigations close to, the building occupants, since most are home. We are available to do these. However, we obviously want to work with the AOAOs and the residents to make sure everyone's comfortable. So we're available to do them, but there are some, reservations there.
Okay, take our next question. Is there guidance in the ordinance or elsewhere on how many units constitute a representative amount? Some percentage of a total?
I can answer that, Liz. So, you're in a quandary with that problem, and the ordinance leaves it up to the design professional. If you wanted to do it statistically, we usually assume a 30 number is a representative sample size, but certainly that can be a problem. So it's just up to the design professional. Depends on the building too. I'd say I do between 10 and 15 normally of the units, and if I start to see things I don't like, maybe more. So it's up to the design professional is the real answer.
Okay, our next question. What smoke management measures can be used to limit the spread of smoke in trash chutes, exhaust vent shafts, and elevator shafts?
I can answer that. So, hi, John. Good to hear from you. That's a difficult question. What you have with the trash chute is really a pretty good situation. The trash chute is typically installed as one unit, and it's usually in a concrete shaft, so it's looking pretty good. You care about where the trash chute inlet is, and it's usually on every floor. If you look hard at probably the trash chutes in your building, there's a self-closing door. Door, I think, is a good description. So it self-closes once you put the trash in. That's actually usually a UL rated door that's rated for hour or 45 minutes, and that's usually the best protection. The best thing too is, I don't remember on your building if you have exterior exit balconies. I think I remember they were interior corridors. Some of the buildings with the exterior exit balconies obviously have the trash chutes on the exterior, so when the smoke happens, it'll vent. One thing you can say is critical though, sprinklers are required in those trash chutes, especially at the bottom where the dumpster is. So you want to make sure the 1 or 2 sprinklers at the bottom in the trash room are properly installed, not damaged, and not dirty or corroded. So I think that would take care of your trash chute the best you can. Probably doing some type of visual inspection. I don't go very far with that because that, for the obvious reason, that's challenging, of the trash chute would be good. The other things, John, I would say the elevator shafts and things, typically you have a rated elevator door. That door that opens up that you see is rated. So then you're really only working about smoke movement from the shaft through that door getting out. And there could be elevator lobbies that help you. There are devices you could do that provide smoke seal over those openings if you felt compelled. I think they're reliable, they're listed. Smoke guard might be the term, and it's a self-initiating made out of plastic sheet that comes down and covers the elevator hoistway. So I hope that answered all your questions, and nice talking to you.
Okay, our next question. What's the turnaround time for proposals?
For us, we're really busy. That's probably, I think I work with Mike, he's in responsible charge here, and I think we do those pretty quick. What do you think that's like, a week, Mike? We seem to be getting that done pretty quick now.
Yeah, generally it's about a week, maybe a day or 2 more, but yep, we can generally turn around pretty quick.
Okay, our next question. If a building was cited by the fire department to change their stairwell doors to allow for re-entry, would it be best to have the fire safety evaluation completed before making alterations?
Yes, that's a hot topic that I'm dealing with every day for the obvious reasons. So I think you should, depending on your consultant that you select, you want to do that, not do that until the evaluation's done, because how you do that is really important, and that's based on the assumption that the consultant can help you execute that. It's very tricky, and there could be other solutions. So I would say get your consultant retained. Then when he comes out, he or she comes out to take a look at it, talk about that and see if they work that out with you better to solve it.
All right, our next question. Have other islands adopted stricter fire safety requirements because of the Marco Polo fire? In particular, I'm wondering about Maui.
Mike, you should pipe in. I've heard nothing from the other islands, and granted, the concentration and number of high-rise buildings in Honolulu kind of drives the ordinance. But Mike, do you know more about that?
No, I haven't heard anything about Maui, Big Island, or Kauai implementing any type of ordinance similar. It may be in the works, but I haven't heard anything.
Okay, our next question. Because of COVID-19, will the fire department extend the deadline?
I can answer that. I just talked to the fire department about that topic an hour ago. We were talking. So I think it's safe to say that the fire department believes that all the evaluations should be done on the timeline that's established today. And they want that to get done so everybody can see what's involved and get their costing. Many of the AOALs will be doing budgeting to handle the renovations that are going to be required. So it sounds like they're going to hold the line on the May 2021 deadline. And I think there could be some latitude on the fix everything deadline, 2024. And when I was just working on the slide when I talked to the fire department representative, I brought up my concern about labor. They said they would cooperate on installation of sprinklers and things because they know that can take longer. I think getting through those assessments, evaluations is going to be interesting and driven. I know the fire department set out postcards. Some of you might have gotten them, a month ago, saying, where are you with your evaluation? Because they're following up and they're actually asking me which buildings did we do and where are we? So they're probably asking all the consultants the same question, try to get a feel for how many are being done. I think they're pretty committed to getting those done close to on time.
Okay, our next question. Can a WJE project manager recommend improvements to achieve a passing score on the Honolulu Fire Department Fire Life Safety Evaluation?
I can answer that. So read that again to me, Liz. I'm confused about one part of it.
Sure. The question was, can a WJE project manager recommend improvements to achieve a passing score on the Fire Life Safety Evaluation?
Yeah, we do that a lot, actually. And that's like a game of prioritizing which are the most efficient improvements you could do and the least onerous. So we would do some analysis of that and make recommendations. That's something we do as much as we do the survey work. It's common we do that. So the answer is yes.
Okay. Next question. What is the most important thing about doing the fire and life safety evaluation?
You know, I'd say from doing these a bunch, you go out there and the ordinance isn't very clear on a bunch of things. Like, for example, I talked about the fire alarm system and how the fire alarm system, is it functional? Is that good enough? Does it have to be compliant with current audibility standards and visibility standards, which it probably isn't? I think getting a fire protection engineer that, you know, is well versed in stuff would help a lot, because you have to make a lot of critical decisions based on experience as far as application of which codes when you make the evaluation of the certain item. So to me, that could be the most value during the evaluation process anyways.
All right, we'll take one more question on today's webinar. Question is, fire sprinkler systems are quite costly. Are you aware of any provisions for smaller AOAOs to avoid installation?
You know, you read the ordinance and it has discretion for alternate methods. So how would we, as a fire protection engineer, we define that as maybe using performance language to scientifically evaluate the building, you know, like that fire model, as much as I showed you there. But I think there are provisions to allow alternate methods. The fire department does like their sprinklers from my discussions with them. So I'd say it's in the ordinance, but coming up with an alternate that would be appropriate would be the question. Sprinklers work really well. Could you prove that another option is, you know, close to equivalent? Going to be challenging, but I think it's in the ordinance, so the answer is yes.
Okay. Thank you, Garner, and thank you, Mike, and thank you all of us for joining us today. We hope it's been educational. As a reminder, you will receive an email with a link to an on-demand version of this webinar that you can use to rewatch the presentation at your convenience or share with any of your colleagues who weren't able to join us live today. And that email will also include a link to access related resources, including a PDF copy of this presentation, as well as a link to download your certificate of participation. If you have any questions, please don't hesitate to reach out to Mike or to Garner. Their contact information is on the screen in front of you. And if you have any questions about the webinar itself, please reach out to me, Liz Pemper, at lpemper@wje.com. So again, thank you so much for your time, and we hope you have a great rest of the day.